Good morning, gems. Today we solve our first full three-point Möbius transformation. We want a function such that f of 0 equals 1, f of 1 equals I, and f of infinity equals 0. This time, infinity does not stay at infinity. So unlike the previous video, the function will not reduce to a simple linear function. We start with the general Möbius form. F of z equals az plus b divided by cz plus d. Now we use the conditions one by one. First, f of infinity equals 0. For very large z, the function behaves like a over c. So if the image of infinity is 0, then a over c must be 0. That forces a to be 0. So the function simplifies to f of z equals b divided by cz plus d. Next, we use f of 0 equals 1. Plugging in z equals 0 gives b over d equals 1. So b equals d. Now the function becomes f of z equals d divided by cz plus d. Next, we use f of 1 equals I. So d divided by c plus d must equal I. Now we solve this equation. Multiply both sides by c plus d. This gives d equals I times c plus d. Expand the right-hand side. So d equals ic plus id. Bring id to the left side. We get d minus id equals ic. Factor out d. That gives d times 1 minus I equals ic. Now solve for c. This gives c equals d times 1 minus I divided by I. Now simplify. 1 over I is minus I. So 1 minus I over I becomes minus 1 minus I. So c equals minus d times 1 plus I. Now substitute this back. The function becomes d divided by minus d times 1 plus I times z plus d. Factor out d in the denominator. Then the d cancels. So the final result is f of z equals 1 divided by 1 minus, open parenthesis, 1 plus I, close parenthesis, z. Now let's check it. At z equals 0, we get 1. At z equals 1, and that equals I. And as z goes to infinity, the denominator becomes very large. So the function goes to 0. So all three conditions are satisfied. This example shows the real Möbius structure. Once infinity moves away from infinity, the denominator becomes essential.